Welcome everyone to our weekly demo series where we help you explore the possibilities of AI and ML with Katonic.ai. In this demo, we'll dive into a fascinating use case, movie genre prediction. We will discover how OTT platforms use machine learning models to discover movie genres from the given overview. We'll start by introducing ourselves and provide a brief overview of our business and services. We'll discuss MLOps and why it is important. Then we'll dive into an interesting and real world use case of movie genre prediction, which will be followed by Katonic.ai platform demo and a QA session. Today, we have Anuja with us who will be leading the demo. She brings a wealth of experience in data science and machine learning and has been instrumental in development and deployment of models on our platform. We are excited to have her share expertise with you. Over to you, Anuja.
Thank you, Prachi, for the introduction. Let's get started with the demo. Okay, so before I start with the use case which we are going to work on today, I would like to first introduce what Ketonic is and why Ketonic even exists. So the basic motto, main motto of Ketonic is to operationalize AI at scale. Now, how do we do that and why do we need it? So basically, what we are actually a platform that is a collaborative platform that gives you a unified UI so that you can manage all your data science stuff in one place. You don't have to go run here and there and use different tools, configure different tools on different infrastructure, and then manage your data science stuff. So this is a very best platform under one roof. You can do everything, and not only that, but even different teams can also collaborate and perform everything in under one roof itself. Now what happens is we actually combines the creative scientific process that a data scientist follow, and along with that, even the professional software engineers whom are required to convert whatever experimentations are being done by data scientists into a production ready scripts. So this is a combination which can be done, and it's very easy to build and deploy any kind of machine learning model into the production very quickly without even taking care of any infrastructure to be provided and taking too much time. That is what we provide, and in a very sustainable manner. Now, a snapshot of till now of Ketonic. So basically, we were founded in 2020. So it's a period where like it was a Corona period. So we started in the Corona period because and till from then we are working remotely, and yeah, and we managed to build a very beautiful platform for you to just use everything within one space. Now, recently we got a funding and CFVC, we have many customers as well using the platform. Not only that, we have patents, and you can see billion of serviceable market. We are serving many customers, not only from single domain, but various across various industries. So this marks that our platform is not built for any kind of specific type of industry domain, but for across like it's very versatile platform, can handle any type of data. And we do have technology partners who have supported us since we have been founded with their infrastructures or cloud. And not only that, we have certain partners who help us take us to different clients as well. So in the form of system integrators. Uh, being since everybody is working very hard, not only these companies but others also, but Ketonic, the hard work of Ketonic team and Ketonic was actually appreciated by different set of awards. So the previous awards which we like right from starting the time we have came into picture, we won many awards, DOIS for best MLOps platform and for best demo award, Go Global Awards, and then we are among Microsoft for Startup, NASCOM, and we are also under NASCOM team. Again, under the Everest Group machine learning operations, MLOps peak metrics, for 2022, we were actually among the major contenders in this MLOps field. So being a very beginner in this zone, but still we managed to be in contenders who are actually in this race since many years. And again, recently we won Frost and Suleiman Award for best practices in the year 2023. So all those, these awards help us keep going and keep producing new feature, enhance our features, and deliver good solutions, better solutions to our customers. Now, what actually Katonic platform is built on? So, if we look into, we have a front view, we have a rear view, and I would say we have a side view. So this is kind of a side view through which you can see the complete architecture of our platform. Starting, if you from the front, you when you see from the front, you are able to see the platform only. So the back end, it's hidden. So that's why I said it's a side view, so that what is actually built layer by layer, a platform is built, and through this side you are able to see how it's built. So from the top, we have the actual users of the platform: data scientists, engineers, machine learning engineers, data analysts. Then what beyond that, how they are using is they can use that our platform for experimentation, model training, evaluation, serving, then creating multiple pipelines, scheduling them, maintaining models into model registry. Behind the scenes are that we support many type of libraries, many types of be it in terms of data sources. We support multiple technologies for deployment and monitoring. We have different types of again technologies that we are using. Again, below, underneath of this is what is being backed, supported, on the top of which we are actually working is a Kubernetes, Amazon EKS, which actually helps us to give an scalable solutions. Again, since we are serverless, we are actually capable of getting deployed on any of the platform, cloud storage platforms. So be it AWS, Azure, Google Cloud. So uh, many of the industries, the very famous cloud storage which they are using are these, and we do support not only this, we go on a hybrid environment and also on premise environment. So it's a mixture of say, scientific processes, all the experimentation the data scientists do. Then comes the software engineering process where the machine learning engineers converts your experimented notebooks into scripts. And then comes the whatever scripts are built by machine learning engineers, they are safely deployed, and the results can be consumed once models are into production. So this is about the MLOps architecture. Now, what components or what features we come with? So starting with what we need for an experimentation for a data scientist is data, of course. So how do we get the data to the environment where we are working? So for that, we provide 75 plus connectors, and very famous connectors, be it S3 bucket, Google Cloud Analytics, to fetch marketing data. All those connectors are available, and you just need to configure with ID and passwords whatever is required. And yes, you are able to set up a source for you, and similarly you are able to set up a destination for you, so that you can just schedule the time how you can fetch the data right from be it hourly, be it monthly, whatever is the requirement of the use case you have. Now, security and control. So what is that? We come with a role-based and a token management concept. So in role-based, everybody, like for every users, we have different components that would be visible to any of the users which we are creating on the system. And token management actually help us that you don't misuse or openly utilize the APIs of the model that is being developed. So in a way, admin of the system can control what type of access or what things could be visible to what type of people is what we provide. Now accelerating the experimentation. So you don't have to worry about whether to install a RStudio, whether to install a VS Code, and then just destroy your machine, I would say, because honestly speaking, RStudio, VS Codes, once they are in your system, its system is like, if we open that, the rest of the components, they would run very slow. So those kind of headache is actually taken care by us. We have already provided you. So with just a button of click, you are able to create an environment for you where you can work, and you don't need any extra skills to use it. It is just the way it is running locally onto your system. It's just that you will be running that on a browser. And again, we there you can just run your codes, you can just train your models, build your models, and you can easily deploy it. And also once you convert them into scalable pipelines, I'll come to the terms scalable and pipelines more when we go to the actual demo. So once everything is done, so you get a complete automated system. So you don't have to take care of anything. You just schedule it, and automatically things will be running smoothly unless and until there's any kind of schema change happening to your experimentation of the schema on that schema which you used for your development purpose. Now, once you build it and then you have a model in your production system, you can just utilize that with the help of an API. So through API, and again, you create tokens and then assign those tokens whosoever would be using the model. And it's very easy to manage also everything. All the models, you can edit it anytime. Everything is already mentioned. All the metadata information is mentioned. So that's come the second point is monitoring and governance. So not only we allow you to deploy the models, but also the usage of the model in the form of resources and in the form of matrices. Like if I say classification model I have deployed onto my system, so the matrices which I will look into are accuracy, precision, recall, etc., etc. So these are the matrices which you might be you would like to monitor, so that you know that your model is still performing the way it was performing when you just trained it and just deployed it into production. And governance, of course, everything is there in one single space. Whatever experimentation you perform, who performed the experimentation, who deployed the model, all those things are captured. So everything is visible, nothing is hidden onto the platform. Again, it is very flexible, open solution which can get deployed to any of the cloud storage, so and can be integrated with any of the data sources. So that's what makes it flexible, scalable. So I was talking about scalable, be it horizontal, be it vertical. So if I talk about Kubernetes. So we are backed by Kubernetes power. So what it does is we don't have to take care about the amount of load if it is coming at any given point. Kubernetes will help actually to automatically scale your pipelines into production without you getting worried or the system getting crushed because of the heavy loads. So it will automatically scale up. And then if the load is decreased, it will automatically scale down. So that's the capacity or capability of the product which we are offering. Now, that was the that were most of the components in general. And now, if I talk about the more related to technical stuffs like data science and coding perspective, so we have what we try to do is we try to address two types of audiences. One audience where they are more actually interested in doing a very low code or no code elements, and just like analyst who maybe they just want to look into the visuals, so just they just want to drag and drop attach things, that's it. the way that happens in the BI tools. So such type of capability are there. We have something called custom components, wherein you just have to configure the columns on which you have to treat your treat whatever treatment you want to give to the column, and you just make a beautiful pipeline just by dragging it, and configuration, a very minimal configurations, which is very easy to understand also, not very technical configurations, I would say. So with that, you can just prepare a pipeline for you, and it will be running in the background. And whatever output screen or the output, whatever howsoever you want to consume the output, is very possible with the incoming data from what from the scheduled pipeline as an output. And again, for data scientists now, not only Python, but we have provided IDs where you can code in different languages. So be it R, be it Julia. So whatsoever you are comfortable with is what we have provided. And again, those type of notebooks or those type of scripts can also be dragged and converted into beautiful pipelines. So no extra skills is required. It's very easy. And again, when we say low code also, so it's like where if you create different notebooks. For example, we know the if I go for a classification problem, I know the set of models I have. I can just create one time all the models and then keep those notebooks configured, and next time if I have any type of classification problem, I can just use the same code and utilize the results of the models. So that's how the low code and again no code concept which we have introduced. So since being it once it's just a one time investment, yeah, I would say, in terms of coding also, and in terms of setting up everything in the production system. So so faster deployment, when we say it, why it is because with a button of click you are able to deploy your model. You don't have to worry about what infrastructure is needed, how to set up that infrastructure, how to collaborate with team who is going to do it, how to continuously ping IT team that whether it is being done, how it is being done, or just it become or just remain in silos, whether what is happening to your model is not known to you. So even a data scientist once known is able to deploy it without the need of a machine learning engineer. So that kind of flexibility is provided. So since everything is automated, so the of course the deployment would be faster. Now we say that there's a reduction in manual labor since everything is scheduled, automated, one time automation scripts have been prepared. So no one would be going there and just trying to run it every day. So till that time, since everything is automated, you can pick up another task, you can do research on another task, so rather than investing time in what you have already built. So that's what we say, there's ample amount of reduction in manual labors because things are already automated. So you don't have to worry about setting up infrastructure. You don't have to worry about running the same code again and again. So you don't have to worry about doing inference, go to inference and then you run it yourself. So all those things are automated for you. Even the monitoring, you don't have to sit back and wait for the outputs, actual outputs, and then apply algorithm and then find out whether you're working. So everything is controlled in an automated fashion. Again, cost effective because it sits on what you call your cloud storage, and those comes with auto scaling capability. So the workload management is very fast. So that's lead to cost effective solutions. So because you don't pay for the resources if you are not if you are not using it, because it is downgraded because of the workload, or it would only be utilized when the workload increases. Yeah. So now coming to the problem statement, which we will be looking into, that is movie on a prediction. So what happens is how the OTT platforms, since we are also built in 2022, and in that phase, all the OTT platforms flooded like anything. I mean, before Corona, hardly people used to watch things on OTT platforms are hardly downloaded also. But with the advent, all the movies also came onto OTT platforms, so everybody started using it. Like the everybody started downloading it because it was the only source of entertainment because people were not going out. So there again, the advantage or the implementation of AI happened. Whenever you watch a movie, of course, you get a notification that since you watch this movie, you can also watch this movies. So all those things are actually a recommended systems that are already implemented on the OTT platform. So how things happens, let's see that. So the problem statement, if I talk about, it's like Netflix need to make sure that the written overviews represent the genre of the movie. So we say, right, what when we say a name, it says whether it's a adventure movie, it's a comedy movie, it's a family movie, or all those things. And it should also match with the content or the summary which is written below the movie title. So most of us first try to read that, and then it's hard for us to understand sometimes whether what type of movie it is, whether it is it's a comedy movie, adventure movie. So that type of movie, with the help of the overview, whatever is being provided, we are trying to predict what is the genre of the movie. So let's move ahead. Before moving on to the actual demo, let's go through what actually happens in the industry in order to prepare any kind of use cases, right? So generally what happens in industry is we don't directly go with the production data, right? Because we even don't know whether whatever experimentation we are performing using this ML problem statement, whether it is even going to be beneficial for the business or not, right? So that's why we call it an experiment. If it is successful, that goes into production. If it is not successful, again that cycle starts with defining a new type of problem, or maybe tweaking another things, maybe getting different type of data. So that's why we call it as an experimentation. So generally, after being having discussions, we come with a set of data, a sample of data, offline data we call it. So then on that, we define a problem which we want to solve. So once the problem is defined, we try to analyze the data, whether the data actually supports to what we are trying to define in the problem. Now, once the data is properly selected, what type of columns we need for particular data, and then we start digging the data. Just check what data is trying to say, what data is trying to answer with the help of graphs. So once we do that, we understand the pattern of the data, that okay, this data, maybe most of the data might be sparse, most of the data might be skewed. So all those things need to be treated, because that will lead to biasing of the model predictions. So in the feature engineering steps, what we do is, after doing all the analysis, we try to we know which columns are good in nature, which columns need treatment. So and what type of treatment is also decided, and all those feature in engineering things happens on different set of columns. We try to convert string columns into numbers. There are different algorithms which are being applied. If there are missing elements, we try to fill it with any type of imputers, be it mean, median, mode. All those type of things we utilize in order to prepare the data for the model. So model in general terms, from the back end, it is actually, from front end is a code, right? But that is based on mathematical aspects, which is based on which the algorithm is built. So in order to run an algorithm, we need data in the form of numbers. So that's why we try to convert those. And if there are large numbers, like now the size of the numbers are big, so we try to reduce it, so that again we save the computation cost. So we try to generalize the numbers, we standardize it, we try to normalize it. All those things happen so that all the data comes in one scale, and then we pass on to model. Now, if I say I have one type of problem, say classification, so I'll have different set of models. It's not only one model cannot give me what I want. We actually try to evaluate different models. So we pass data, we train multiple models. Now, after training multiple models, we see which model performs better better in terms of parameters. Now again, different set of model problem statements have different set of matrices which are used so that models can be evaluated. So as I said, when I am talking about classification, I have matrices like accuracy. So this parameter is not actually very heavily applicable to all type of problem, because sometimes when we have imbalanced type of classes in our target columns, so at that time it might give biased results. So for that also we have different set of other type of matrices like precision, recall, F1 score, and different permutation and combination of these elements. So once we identify that this problem, for this problem this is the best matrices on which we can actually evaluate the model, we go ahead with it. And if we get the better results on that matrices, then we again try to actually tweak certain parameters and see whether our model performance is improving. If that is done, and then we come to conclusion maybe that okay, this is the model after comparing. But if I do thousands of iterations, right, so I won't be able to remember under which experimentation what parameters I tweaked, what were the value of which parameter that led me to this particular solutions. So it's very hard for anybody to just write it down every time what is happening. Maybe something might get lost. So for that, what we have is experiment tracking system. So here what happens is either you perform hundreds, thousands, lakhs of experiments. All those things are tracked. You can track data also. You can your notebook, whatever code you did, that also you can track. All the environment variables, maybe you might have changed some package. So that is also the version of that package can also be tracked. Matrices also can be tracked, and all the parameters which you use can also be tracked. So it is very easy. You don't have to worry, automatically that is being done. And after that you can just click on just to compare all the models along with the matrices. So the moment you identify it with the help of comparing all the experimentation which you did on the matrices, that this is the model you are going ahead with within production. So you just dump your experimentation code into a repository. Now, since this is whatever experimentation we did, it was on actually on notebook, but notebook cannot go into production. So we need a scalable pipeline so that it goes into production and can also be scheduled so that the complete system run in in a smooth manner. So therein comes the role of ML engineers who also can work on the same platform. So both the teams, data scientists and ML engineers, can collaborate within the same space. So this actually improves collaboration between them, communication between them. So once the data is in the hands of ML engineers, they build a beautiful pipeline, scalable pipeline out of that. So be it a training pipeline, be it inference pipeline. So once training is done, that pipeline is built. And in order to run that pipeline, what we have is source system. We need to connect to source system. So till now what we did is we used only the offline data, that is a sample data, right? So that won't be useful for me in real life, because if I want this go system to go in production, I need data sources, original data sources from which I will be fetching data after certain intervals. So I know the schema which my model needs. So I'll identify the type of sources from where that data came, and I'll just attach it to my pipeline so that it runs. But I have no system to do it. So for that, we have connectors. So we have multiple connectors, very famous connectors, which will help you actually connect your data sources to the system. So with the help of connectors and that connectors and the data is now being fed to the pipeline which is being created. So first time, if I am running in the production, I'm running the model training process. So a complete process would be running, and one of the model will be registered. So registered means just making an entry. In normal terms, in normal terms, if I just go ahead, it's like maintaining the entry is somewhere. So here we are maintaining the model which is going into production so that it is helpful. So Combining the experiment tracking concept and model registry, it will help me reproduce my data anytime, all the experiment anytime. So versioning of the model is maintained with the help of model registry. So once the model goes into production, so how should we consume that model? So what we do is, for that we provide model APIs, and one more is feedback API. So model API, you can use that API along with token management, along with token, and can utilize that API outside the application or outside the platform also. So that is also possible. It can act as an input for other application. Second is web application. So within the same platform, you can develop a web application, be it Streamlit, be it Dash. Those kind of applications can be developed and again deployed onto same platform. So you can consume whatever models you have made. You can consume the result right away inside that. But not only that, we don't restrict actually to utilize our system. If people already have BI tools with them, right? So we don't force to take whatever we are providing. We also provide a visualization tool. So the API is easily integrated with the BI tools which the organizations have. So that flexibility is being provided. Now, now the system is in place. I need to understand whether my model is still performing well the way it was performing in the training aspects. So for that, we have a performance monitoring system. So with every original, or I'm talking about the original or the true label in technical terms we say. So for every true label, if I get it, I am able to go in the feedback loop and just able to understand whether my model has predicted it well or not. So with that, my matrices would be updated accordingly. So I would be knowing well in advance that, okay, my model performance is going down. There is something fishy going on. Maybe in a new type of data might have entered, new schema might have changed. So with that real-time monitoring system, you can just go ahead and just tweak in where the problem is. And again, you can move back to the system once everything is set up. So it is a one-time effort. And once if you feel that you can just retrain, the pipeline is already built, you might just need to change in one of the file and complete system will go up once everything is in place. So this is about actually, I would say, a pictorial representation of our system or our platform. Let me go to the platform first. So this is how the platform looks like. The moment we log in, the first page actually captures the recent activities. So be your pipelines which you have run or the workspaces which you have spent. Now we also have something called Katonic Help Center. So in the product itself, you get a variety of elements, whether you want, if you are working on any of the component or you are stuck on how to use it, we have documentations for it. So you can directly just go ahead here itself. You don't have to worry and search for the documentation where are those. So it's available right in front of you. Even if you face some error, you can raise a ticket that to ask the experts help. And not only that, if there are feature, if you feel okay, this feature should be there, you can request a feature for us and we'll help you just deliver that feature for you. Again, you can just connect us through Slack also. We provide a small MLOps course just to make you through if you're a beginner and you just want to understand the terminologies which are going around. So you can just use it for your perspective. So all those under one roof. Now moving on to the first component, that is connectors, which I was talking about. So we have ample amount of connectors, very famous. So if you want your data to be fetched in certain intervals from X source to Y destination, you just define what type of source you want and you just define what type of destination you want. So all those, this is existing. If you have already set up, so you can just select, because you don't have to again and again set up the same source, or you just set up a source, another source if it's not available. that is done. Once you set up source, once you set up destination, you are up for any kind of connection. So let's check one of the connections which are already available. So if you see yeah, very first, so it's like fetching the Google Analytics data to the S3 bucket, to your S3 bucket. So you can actually either do it manually, or you put a cron job so that your data is fetched at regular interval, or maybe every hour, depending upon the use case needs. So once you configure all those things, the data will automatically be fetching. If you do it manually, so you can just go ahead and fetch certain amount of data. So all these things are possible. It not only that, it also gives you what type of column, what type of data or the tables you want to fetch. It's not necessary that you need to fetch all the tables, or specific tables can also be fetched out of it. So this is about connectors that will help you bring the data to the system. So we don't force anybody to store the data into our platform itself. They can store anywhere, and definitely with the help of code, they can utilize the data. Now we also provide one more space area that is called file manager. So wherein you have two areas or buckets, that is private bucket and shared bucket. So private is where you keep all your files under that are private to you, cannot be visible. Shared is if you want to share some files across your team, so that is where you can store. And not only that, it maintain a version. So by mistake, if you uploaded a file with the same name that was not supposed to be, yeah, still the previous version of the file is available and you can download that. So that flexibility is also being provided here. So here, if you see, all the versions and all informations are there. So the 8 versions of these files are available. So that's what. Now coming to the ID. Now I have the data. I know maybe in the same environment I can keep the data. Now I want to use that data. So we let me just help you create one. So as I said, we provide multiple areas under which you can work it, be it Jupyter Lab, Jupyter, VS Code, R Studio, and there is one more component called Katonic Studio, which is our low code, no code platform. And there you can also build a pipeline using drag and drop component. I will go through it later. Just telling it. If I want to work on Jupyter Lab, I have certain environments to click on, and those environment will be created for me, and I can definitely work. So I don't have to worry about installing any kind of Python or any kind of packages also. So that you can just select from here itself, and the amount of resources you required in order to just run the project or develop a model. Since most of them are already created, I'll just go through them. Not only that, what we do is we provide usage of your workspaces and some of the metadata, how much resources and how long it is, live logs of it. And if you don't, so if you are logging it out, so you can just chop it so that your resources are not utilized. I mean, you save the resources. And if completely your project is completed and everything is done, you can directly delete it also. So those kind of things are there on the platform. So I'll be moving to the Skatonic Studio element. Or rest of the elements are same. VS Code Studio looks like the same. There you can also build applications. So that's why you see live application button here itself. So let's move on to Katonic Studio, what it does. So I've connected. I have already opened that. Till the time it opens, I have already opened that. Now, before moving to the actual use case, let's see the interface, how it looks like. So here, when you come up, the look and feel of this is Jupyter Lab. The only extra element that comes in is our editor, pipeline editor. We call it a canvas because we can draw any customized pipeline for us. So it's not rigid. Once you draw, you can again redraw it or recustomize it. Not only that, what we do is, as I said, we provide certain components for no code level of audience. So the moment if you understand, if I take one example, um, suppose I have with the help of statistics, I know what type of labels need, what type of column needs, what type of treatments. I understood from this type of card. I can directly go ahead and just start applying, just drag this component, configure it, like just write the input, all the information, what input I need, what type of columns on which I need this. And no, all those information I can just drag in the form of pipeline and I can create a very beautiful pipeline without any code. I can just connect them so that I know which will what component will be running after what. So this is kind of our no code elements which are being provided. Now, if you don't want to use it, if you want to actually code for you, again, we don't restrict anything. You can definitely go ahead and actually build your own pipeline. So for that, I'll be showing you the examples. So the only thing is, let's go to the original notebook. Now I did a development, and under that development, for example, the my use case which we are working on is movie or not. So for from TMDB, the data is what I am getting, and then with the help of the overview of the model, I am actually overview of the movie. I am actually trying to guess what type of genre that movie comes under. So I perform all the operations first, right from first fetching the data from the open source TMDB. After doing that, I try to actually understand whether there are some incomplete information in my data. Now, maybe I have fetched the data where the overview is not present. So if the overview is not present, so it's hard for me to actually give what type of that movie comes under. So those type of movie I will just remove from my training data set. And then whatever fresh data I have prepared, and I can just move or I just apply all the feature engineering techniques since it is a multi-label problem because one movie can come under different labels, genre like adventure, comedy, family. So for that, we need the model should also understand. So we also convert those type of labels into numbers. So in terms of data science, we call it vectors. So the unique words are actually converted into one column. So I say adventure is one column. I say comedy is one column, and this way we have certain 19 unique elements, and then whatever under whatever labels that particular movie comes in, there I'll get one as a value inside the vector. My vector is formed like 0 0 0 0 0 0 in inside brackets, square brackets. So I just define it one. Now since it is a text, I am dealing with NLP type of use case. I have to clean the text because text a model won't understand. I need to convert this text into numbers so that it model is able to understand that. So for that, I clean my complete text first, all the removing stop words, punctuations, because those are not needed. We need a very basic term. So if I say studying, studying, studied, all they come from is study. So I want them to be converted because again, studying, studied, they become a separate words for a model, but that the meaning is same, right? It comes from study. So that way is what we do processing in NLP. Now again, we divide them into train and test, apply different models, decision classifiers and k nearest neighbor and etc, whatever type of models we want. So all these things I have done in one single notebook. I'll run this notebook. It will take time. Now what is happening is, if you see, I have to wait till decision classifier is completed. Then only I can start the working of k nearest neighbor, right? So this is a sequential type of running. So I have what I have to do is if this k nearest neighbor required 4 CPUs, right? And if decision classifier required 2 CPU, but I have to assign my complete notebooks so 4 CPU. So even though the steps are not using that much amount of CPU, still I have to assign my notebook to that because my one of the step needs that much amount of resources. So it is like unnecessary your resources are getting wasted. So we have a solution for you for that. What you can do is whatever code you wrote, right? You just convert them into smaller notebooks. So this again reduces your computation because as I said, right, in notebook, you have to do it one after the other. First is decision tree classifier, second is KNN. So here, if you attach them in the form of notebooks, these can in the form of pipelines. So here they will be running parallelly. So again, the computation cost is reduced. And what I was talking about resources. So in order to run this pipeline, what is that is needed is I'll just go this way. Yeah. So here, if you see, if you click on any of the node, there are basic configurations that needs to be addressed. So be it the path where you need the data from, and again, most of the information like CPU, you can also assign CPU, GPU node property. If you go to pipeline parameters, this is pipeline property, which will be assigned to one of the notebook. Now, if I click on this particular element, what I need is you can specifically define that, okay, for this notebook, I need 4 CPU, I need this much RAM, I need this much GPU. So that GPU will be utilized by this notebook only. It will not go any other way. Again, similarly, you can define separate type of resources to other types. So in this way, you are saving your resources. You are using it whenever is required, unless and until you are just defining in the very starting, and then your resources are not utilized to its fullest. So this is how we actually create the our code into beautiful pipeline. Next time, if you want that you need one more model to be attached, you can just drag this one of the model code and just attach it. So once you create the pipeline, you just go to run, save, and just run in the pipeline config. That means you are now running your pipeline onto Kubernetes and platform. So let me go to Kubernetes platform. So if you see, the pipeline has started, um, and you will be able to see the live logs of what pipeline is running, what is being done, what data is being like what package is being installed. So all those things are captured, and the logs are also saved not only here but in the form of files also. So I'll just go through the one that is already run. So if so the structure and the feel and the look is same as what you designed on the platform UI, right? On the Jupyter Lab environment, what we call as editor. So here, everything, all the green dot means that is being successfully run. Red dot, if it occurs, that means there's some issue in the pipeline component, and you can just go back and just check it where the issues are. So here, see in the form of files, your logs are actually captured. Now these two components ran parallelly. That saves your time also in the form in computation timing, and scalable. Again, whatever these actually they are running in an isolated manner. So scraping data don't know about the data preparation. It just sends out the output, and that input is consumed by data preparation. So data preparation is dependent on scraping. So since they run on in independent environment, so there is no conflict about any kind of packages, and they will also automatically they will scale up and down according to the needs of the resources or the load at that particular time. So not only this, you can, as I was talking, you can also actually just test run. The pipeline I'm choosing is movie owner. uh, Experiment, again I can see movie owner using an experiment, and you can schedule them. So we use it periodic or cron. In cron you can just write what type of experiment you want, when to start, when to end. And in periodic, again, what happens is start date. You start from where you want this pipeline to run till when you want this schedule activity to happen. So started from 12 to 19. I want this to run daily for me. So starting from this, now you can also configure that either you want it every minute, every hour, every day, every week, every month. So right now, let's just say every hour. So I just started, and let's go to the recurring run. So things have started. So if you see, others are also there. I just click on this. All the informations are already available for me. And if you want that this needs to be disabled, you can just go click on disable. It will not run on the scheduled time. Or if that is not needed, you can also delete this. So that flexibility is also provided to you. Moving forward to this is about pipelines. Now we were talking about experimentation also, right? How the things are being saved. So all the experimentation which I did, I'll go to the movie Yana prediction experiment. And when I run, so if you see, this was run previously, still the new pipeline which we ran will be running. It will take some time to run. So if you just drop it, you see this was run using hyperparameter tuning. That's why you see plus here, so that a base and whatever parameters, extra parameters we have given, all those information are captured. If you see all the numbers, accuracy, matrices, and what all parameters you used, or not only that, extra also you can add here features, what type of features were actually being used here. So all those things are easily trackable and can be seen by anybody. So anybody who is using the platform. So if I click here, it tells me about the information. Just let me go back to one of the element. Let's say this. Okay, clicked on this one. So it gives the detail artifact information about what is being done. And not only that, things like if you want to compare what type of data, or okay, let's compare this all these elements. Um, and just you need to see the information, or you need to understand that which model I should select, because the accuracy or the F1 score, all those parameters are very near to each other. You just click on all the experiments you want. You can just compare them. You can just select what type of matrices you want them to get by compared. So visually also it gives you better information, so that you can select the best model out of that, so that it goes into production. So let's see, all these actually are the base runs. So if we see here are the actual models, if I click on this, all the information about the model is there. What parameters, requirements were being used to deploy the model file, all those things are tracked down here. And if I say that this is the model, I want this model to go into production, I just click on this model. I just select this model to go into production. So if this model was already been in production, you would be able to see in the list of the models. If not, you just register it first time. It will be registered in the version 1 form of it. So I see the model is registered now. Now I go to model registry concept. I see this is the model. As you can see, version 1 is already there in the production. Now I have version 2 that is recently been available. Now the stages are very important, because the first stage is none stage, even though it looks not promising none, but for organizations to move a model into production, they have certain list, they have certain checklist that is to be passed, so that these models are production ready, and they follow certain compliances to be in production, be it a schema or anything that is being defined by an organization should be checked, should be checklisted before moving it to production. So when that is done, then they move the model to second stage. If not done, then rejected. I mean, the second model would go into production, which passes this checklist. Second is if after none, people second stage is staging. So under staging, what happens is so no code that directly goes into production. It first remains in development environment for developers to develop. Second, it goes to tester in the testing environment, so that it checks whether the model is performing well, and it can is able to handle certain level and logically correct, and whatever is expected, it is delivering. That is what checked in the staging stage. And once that is passed, we directly move that model to production. So if you click this transition, so what will happen is whatever version of that model is in production, that will go into archive state, and this will come into production. So now the stage is production. So now it has gone to production. Let's see how we can use it. I go to the deploy section, model deploy, click on model, name I give is test movie. Since we deployed it on Katonic model registry itself, that's why we are selecting the model source as this. There are different sets. Custom model will help you whether if you have already built your models, you can just bring them with the files and the template we are asking. If those files are in that template, then you would be able to deploy already developed models. Here you can develop and save everything in our registry, and from there you can deploy a model. So model is movie owner type. The model version is just now we have selected. Now it's NLP type of problem. Scaling. See, we also provide an element of scaling. So if you know that this model is going to be heavily used, so you can just define the range. That in that way, it will be auto scaling and downgrading. And if the if the impact is very high, then it will automatically scale up. New node will be attached to it. Now resources, how much resources would be required? And just click. So see, with the button of click, my model is deployed. So if you see, I have already deployed a model wherein we provide APIs in the form of prediction and feedback. Feedback is for you for monitor cracking the monitors. Now create a token. As I said, APIs won't be utilized of no use unless you create a token for it. Now existing tokens, if you already have docs usage, will help you to how you can use your model. You can do a one-time check for your data, like whether your model is performing well or not. Just pass that input and see the result of it. Same happens for the feedback loop. Usage of the model in the form of resources, CPU or be it GPU. If you have all these are the live logs when your model is actually in configuration state. Monitoring, let me show, since this is model just deployed, I'll show you the other model which is in production. So this way you will be getting live stats of all your matrices, and whatever matrix you use for actually you used while evaluating the model. If that goes down, you can just go ahead and check what happened to the model. Edit option will provide you to update if there are certain model version change or resources change, or if you understood that it's a heavy usage model, so you just improve the pod like the pod numbers also. And again, if you don't need, you can just delete it. So this is all about model. Same way applications, I have already opened developed application for the same use case. Let me just go to that, which is one already open. So here I have just added the overview of what we say Titanic movie, right? So I just clicked on prediction. So it gave me that it's a documentary movie or a TV movie. So this is how it's since it's available in a public repo, you can just clone this application and you can also try deploy it. So again, usage logs, all this information for application is also there. Here, the one thing that is needed is you put your code into GitHub, and through GitHub, it could be easily deployed onto systems. Again, visuals. So what we do is we also provide a visualization tool wherein you can develop beautiful applications for you. So if I take an example of this, so similarly, all those informations can be actually, if I say, let's say incoming calls, if I have one, so all those the kind of charts can be deployed out of the data which is being passed on from one of the pipelines. So this is visuals. Accelerators, these are best source of actually we have collected all the type of use cases that are available, that would be possible under different type of categories, under different industries. So all those are there. So some are free, that will actually have notebook for you and applications for you design that will actually give you a base so that you don't have to start from scratch. Most of the codes are already written. You just tweak certain things and then you can create a customizable application and code for yourself. If some person is admin, they can control what type of users they want for this system. License, they can monitor how many users, and cluster, although all the type of monitoring that is being required, user monitoring, be it platform monitoring, all the components that are being used. So all those type of information they can track. So if something goes up and down, admin is able to inform people directly. So within a same platform itself, one more team can help you understand whether where the things went up and down. So that's all about the complete platform. Over to questions and answer.
Thank you, Anuja, for such an insightful demo. I learned a lot through the demo that you gave us. I'll be opening the platform to the attendees. If you have any queries, please raise your hand and I'll move you to speaker panel. We will wait for around 30 seconds. If nobody raises their hand, conclude the session.
Yeah, sure, Prachi.
Looks like we do not have any queries coming our way today, Anuja. Thank you so
Yeah,
much for
no
taking
worries.
this session. Yeah. Thank you so much, Anuja. We'll see you again next week, same time.
Yeah, sure, Prachi. Thanks
Thank
again
you.
for
Bye
this
bye.
opportunity. Bye bye.